Hello, this is Rick from MathX, and today we'll be doing number 23 from the 5th, 6th grade Math Kangaroo. Now, this problem's hard because unlike a lot of other questions on Math Kangaroo, there's not a specific math concept that will help us target this question. For example, if we're good at algebra, we can't really use algebra in this problem. If we're good at geometry, we can't use geometry. There's nothing we can really do directly to attack this problem, no concepts we know in advance. This kind of problem just tests our ability to use logic and reason to solve the problem. Now, since most of the problem in this case is considered in the answer choices, we must also look at each of the answer choices in depth. So when I read the question, I'm also going to read each of the answer choices. And after that, we will analyze each of these answer choices to deduce which one's the best one to pick. So without further ado, let's get into it. Robert made 5 statements, A through E. Exactly one of these statements is false. Which one? Statement A. My son Basil has 3 sisters. Statement B. My daughter Anne has 2 brothers. Statement C. My daughter Anne has 2 sisters. And statement D. My son Basil has 2 brothers. And statement E. I have 5 children. So in the problem, it tells us exactly one of these statements is false. So that means if there's one false statement, everything else, the 4 other statements, are all true. So to find the false statement, we have to go through each of these cases to find out which statement is false. All the other statements can remain true without any contradiction. So we must test this elimination approach to find out which is the best answer. So let's do that. Statement A. My son Basil has 3 sisters. If statement A is false, that means that Basil does not have 3 sisters. So, since A's are false statements, that means all the other statements are true. So, while Basil does not have 3 sisters, Anne has 2 brothers, Anne has 2 sisters, Basil has 2 brothers, and I have 5 children. Robert has 5 children. This poses a problem because option C tells us that Anne has 2 sisters. Anne is obviously a girl's name, telling us that there's 3 girls in the family. Now Basil is a boy because it tells us that it's our son Basil. So it tells us that there are 3 girls in the family, his daughter Anne and the 2 sisters. So that means Basil will have to have 3 sisters. However, we're taking option A to be false, meaning that Basil does not have 3 sisters. These 2 cases cannot coincide with one another. Basil can not have both not 3 sisters and 3 sisters at the same time, meaning that A cannot be the case because we reach a contradiction that doesn't work. So then we go to option B. My daughter Anne has 2 brothers. If we take this statement to be false, then that means Anne does not have 2 brothers. So then we look over all the other cases. That means that every other statement is true. My son Basil has 3 sisters. My daughter Anne has 2 sisters. My son Basil has 2 brothers, and I have 5 children. But we know, since B is false, Anne cannot have 2 brothers. The problem with this statement is, then A, E, and D will all pose trouble with each other. Statement A says that Basil has 3 sisters. Statement D says that Basil has 2 brothers. And we know that Basil is one of the sons. So 1 plus 2 plus 3 would give us 6 children in total. However, statement E says I have 5 children. We can't have 5 children and 6 children at the same time. We reach a contradiction. So thus, B cannot be our right answer. Because all the other true statements would not work out with one another. Then we look at option C. My daughter Anne has 2 sisters. If we take this statement to be false, then that means my daughter Anne does not have 2 sisters. And all the other statements are true. My son Basil has three sisters. My daughter Anne has two brothers. My son Basil has two brothers, and I have five children. Here we reach the same issue as before, with all the other statements being true, except for the daughter Anne not having two sisters. We have our son Basil having three sisters, and our son Basil having two brothers. Basil plus the two brothers plus the three sisters give us six children. However, E says, I have five children. As I said before, we cannot have five children and six children at the same time. This is a contradiction. So, since option C will lead us to a contradiction, it cannot be our answer. Let's check out option D. My son Basil has two brothers. So, since we take option D now, that means option D we're going to take as our new false answer, meaning that my son Basil cannot have two brothers. If that's the case, then my son Basil has three sisters, my daughter Anne has two brothers, my daughter Anne has two sisters, and I have five children. Looking at this case, we realize that it doesn't seem wrong. For example, if we count up the number of children, we have Basil, we have his three sisters, and we have two brothers. And this may seem wrong at first, because then we're doing 1 plus 3 plus 2. But remember, Basil is one of the two brothers. So we have 1 plus 3 plus one other brother, giving us five children. This matches up with answer choice E. This sees that D could be possible. However, it's easier to prove wrong than to prove right. So let's check if E is wrong. If E is wrong, then we have confirmation that D is the right answer. However, if D is controversial, then we're going to have to do deeper insight. So let's go to E. I have five children. If we take I have five children to be false, then then that means all the other statements are true. My son Basil has three sisters, my daughter Anne has two brothers, my daughter Anne has two sisters, and my son Basil has two brothers. Now, the problem with this is statements B and D. My daughter Anne has two brothers, and my son Basil has two brothers. If Basil has two brothers, and Basil himself is a boy, that gives us three boys. So his daughter Anne would have to have three brothers. Well, we can't have three brothers and two brothers at the same time. That just doesn't work. Two does not equal three. So we can eliminate E as an answer choice. So going back to D, D seemed like it had the only answer that made sense, as we couldn't find a contradiction in it. All the other answer choices, we could find at least one contradiction with it, meaning that D is our best answer, and that when D is false, the story seems to work out the best. So D is our answer in this case. Now, this problem is messy, and it's not easy by any means. But since we worked smart and eliminated all the wrong answers, we were able to solve it. So in a problem where you don't really know which one is the right answer, because all the answers are kind of close to one another, the best choice is to eliminate all the answers that are wrong. Because once you eliminate all the wrong answers, you're only left with the right one. And this can be used to solve many confusing problems, just like this one.